Hi, hello, namaste. Welcome to Pardus tutorial. I am Madhavi. And as you know, in this Pardus tutorial channel, I am explaining the topics which are about the physics subject and IIT and non-IIT, JEE, non-JEE, all the syllabus I am explaining here. So recently I have taken from the 10th class reflection of light in a curved surfaces. First lesson I am still explaining now. So related to this, I think six parts are done. This is the seventh part. This is the seventh part which I am explaining to you now. So in the previous parts, in the part 1, part 2, part 3, part 2, part 1 to part 6, I have explained about the what is the reflection and how the reflection will be takes place in the case of a spherical mirrors, and there are two spherical mirrors, and how the light ray will be travel in the two different types of mirror, and how, what type of images will be forming in the two different cases of mirrors. Yes, and thereafter two important formulas also I said you, and which is very important. Ray diagrams are important in this first lesson for the 10th class especially. Actually this topic is useful for all students, not only especially 10th class. Okay, this is useful for all in the case of the optics. So now this is what which is there in the 10th class syllabus. Now for you the important questions I can say, ray diagrams whatever I explained to you, those are very important. Image formations also important. And in the last part, which means in the part 5, in the part 5 I have explained about the sign convention, right? Sign convention is also important, and as well as the two formulas I said you know. So which is r is equal to 2f, another one is 1 by f equal to 1 by u plus 1 by v. These two formulas, what is that? 2 is equal to, sorry, r is equal to 2f, one more formula 1 by f equal to 1 by u plus 1 by v. Am I right? These two formulas which is overall there in this lesson, and one more thing is also there which is about the magnification. Well, let me tell you something about it. So up to now, okay, we can calculate with using the f and u. We can also find out where is the v actually. Okay, we can find out, and with using the sign convention also I have explained. And let me tell you, so where the position of the image is forming, where the object is there, suppose if you know image distance, we know focal length, we know of a mirror, we can predict, we can calculate u value. Okay, but where position we can predict with using this formula, but what type of image is forming we cannot say which is smaller or bigger or same size or magnified or thinner or magnified or erected or inverted, yes, or real or virtual, we cannot say with using this values, right? We just have to predict where the image is forming exactly. Okay, to know the type of image or to know the characteristic of image, yes, we wrote the characteristic under the image formation, right? Which is a smaller or bigger or magnified or diminished or real or virtual, erected, like inverted, all things we have mentioned in the case of properties of image in that answers. So in the same manner, so how do we know the properties of image? Is how can we expect? Can we we should have to by heart now? No, we don't. You don't need to by heart anything about the characteristic of image. So if you know about the magnification, am I clear? So we'll see. So actually based on this we have to done some problems. So my intention is it's better to solve the problem after learning about the magnification, but before that also, just as an example I will tell you here. Okay, so I am telling, I am keeping an object of 8 centimeters, a distance of 8 centimeters from a concave mirror. So which means simply in the problem they will not give the diagram, we should have to draw. So okay, so they are telling if it is F, if it is C, they are telling the object distance is 8 centimeter. So suppose 8 centimeter and focal length is 5 centimeters. Am I clear? Focal length is 5 centimeters, object distance 8 centimeter they gave in the problem. So how they will be tell means, they will ask the question, find out the image distance of a focal length 5 centimeters of a concave mirror. We are keeping an object in front of a concave mirror at a distance of 8 centimeters. Am I clear? So from that in the physics we have to write F is equal to 5 centimeters they gave, U is equal to 8 centimeters they gave. Am I right? So now before taking in the problem they will give you positive values only. But after writing we should have to apply sign convention. F is equal to 5 they gave, but almost in the concave mirror, if you are keeping an object, suppose the object is there, because f are 5 they are telling, and r will become how much? R will become 2f, right? Which means 2 into 5 centimeters. So r will become 10 centimeters. But where is an image? Where is an object? At 8 centimeters. Which means we can predict it will be in between the f and c. Am I right? Yes. So in the same manner. But so here the incident ray is in this direction. We are measuring the u in opposite direction. Which means object distance we have to take as a minus 8 centimeters. In the problem they may not give you minus and plus. They will be give only positive values, but after you only have to apply sign convention and we only have to solve the problem. Am I clear? So now focal length also. Focal length is also minus 5 centimeters. And in the same manner r is equal to minus 10 centimeters. Am I right? So now what they are asking? They are asking the image distance. So we should have to use this formula. Mirror formula is there now. 1 by f is equal to 1 by v plus 1 by u. Okay, 1 by u, 1 by v if you are writing separately. If it is a plus in between, we don't. So nothing will be changed, right? So now see. So 1 by f. What is the f value? Minus 5. We don't know. And what is the u value? Minus 8. Okay. So this minus 8 I am taking this side because we know 1 by f. So minus 1 by 5 plus 1 by 8 is equal to 1 by v. So I am taking 1 minus 1 by 8 this side now, plus it will become plus. And 5 and 8. If you are taking 5 ones, 8 and 4 twos, 2 ones. So which means 8 only. 5 8s are 40. It will become 40. Yes, LCM will be 40. Here it is minus 8 plus minus 8 and here plus 5. That's it. 8 5s are 40 and 5 8s are 40. So will become 1 by v. So minus 3 by 40 is equal to 1 by v. So here if you take, actually we know we have to know v value, not 1 by v value. So I am extending this one, which means v is equal to 40 by 3 minus 40 by 3. Just I am taking reverse. So now 3 ones are 3, again 3 threes are 9, again 13.3. This will be bar, you already know. So 10 by 3 means a 3.3 bar, like that, no, bar. Okay. So v is equal to 13.3 centimeters. Which positive or negative? Negative. Okay. Where is the image is forming? After 10 centimeters. After 10 means beyond the center of curvature. You already know, right? If you are keeping an object between f and c, where the image will be formed? Draw the ray diagram. Draw the ray diagram. It will be formed beyond center of curvature. Yes or no? So v of image distance will be there at where? 13 centimeters. Minus means opposite, this side. If we are getting v positive, whether image will be forming in the same direction of incident ray, which means behind the mirror. But now this is a way to find out the image distance. If you know image distance, if you know focal length, you can also find out the third one. If you know any two, you can find out the third one. That is simple. Okay. But we can predict the position, in which distance the image is forming, in which distance object we are keeping. We can find out with using this formula. But we cannot say, we cannot explain and we cannot predict what type of image is forming. Which means characteristic of image we only have to know by the magnification of a mirror. Am I clear? So let me tell you that important magnification to you, and thereafter this is about the problem solving of with using the mirror formula. Am I clear, all of you? Fine. So now we'll discuss about the magnification. We'll discuss about the, and for you who are watching this video, for you I am giving one problem to you. So I am keeping an object in front of a concave mirror at 2 centimeters distance and which have a focal length of 5 centimeters. Then find out the image distance v. Object distance is 2 centimeters, focal length is 5 centimeters. Find out the image distance. Okay. So you can please try. V will be positive or negative. You just have to comment below. Okay. You have to comment below which is and which type of image we have to see. Okay. Where it is forming in front of a mirror or behind the mirror. We can predict based on the sign. Am I clear? So now see. So next important question. This is also one of the important definition. Magnification. Mostly I'm covering all the important topics only. Mostly I'm covering all the important topics only, not rather than that. Okay, mostly covering all the important topics in this channel. So we'll see the magnification. Magnification, two definitions we can say. So which is what, the ratio between the image distance to object distance. Okay, the ratio between the image distance to object distance. So that one also we can know, we get know from the, if you're taking a concave mirror. So this is C, this is here an object. Okay, again we are taking, here image is forming. Okay, so now here u value opposite to, so is negative. What is the v value? Is also negative. What is f value? Is also negative. What is ho value? Positive. Above, hi value is negative. Am I clear? V by u minus v by u, it will be the ratio between the these are the values. We'll see the ratio between the, why we are getting minus, the ratio between, simply let me tell you, the magnification is the ratio between the image distance to object distance. Okay, simply. So the definition, the magnification in a mirror, in a spherical mirror, is defined as the ratio between the image distance to object distance. Okay, so which is m is equal to minus v by u. Minus is why we are getting minus, I will explain to you now later with using the derivation. Okay na? So this is we are taking as a equation 1. Again one more definition also we can write, which is also the ratio between the height of the image by height of the object. Am I clear? Height of the image by height of the object. From the second definition, hi by ho. Okay, from these two, from equation 1 and 2, m is equal to minus v by u and is equal to hi by ho, we can write minus v by u is equal to hi by ho. This is the magnification formula. And why we are getting minus v, I will explain to you now. Okay na? I will explain to you now. Okay, so now let me tell you why we are getting minus v. From the derivation only, a small derivation, let me explain that one to you. So the same, okay, the same thing, let me take the same thing here. Can I draw which is a little bigger? Okay, the bigger diagram, let me draw. This is a pole, center of curvature, focus. So I am keeping an object here. From this object, here, this one. Am I clear? So now this point I am taking as an object, O dash, and so this is object, O dash, or I dash. Yes. So now if you are taking like that, then O dash, I dash. Okay, fine. Leave. Okay. Here. So from the definition of the magnification, the ratio between the height of the the ratio between the image distance to object distance, right? Image distance is what? Pi. So m is equal to v by u. Simply minus. Why we are getting minus v? I will explain to you. So the ratio between the v by u, what is the image distance is pi. Okay. By object distance is pu. Okay. Next term is equal to, finally we got now m is equal to, let me write. So from the two equations, minus v by u is equal to, and m is equal to hi by ho. Okay, actually this is the thing. This is the based on the definition these, but minus whether we are getting minus or not we don't know, but by this derivation you will know that one. Okay, so we'll see. From these two, v by u is equal to hi by ho. So we'll see in this diagram, what is v here? P to I, pi. What is u here? Po. What is hi? Hi means I dash, right? Height of the image. HO means O, O dash. So now apply sign convention for these lengths. PI, P to I. We are measuring in a opposite direction to incident ray. Incident ray direction is this side, but we are measuring the PI in the opposite direction to incident ray. So which is positive only. Positive, sorry, negative V. I'm so sorry. Negative V. By, so object distance also we are measuring in opposite direction only na, to the incident ray. Yes. That is will be minus U. Am I clear? So now, then it will become positive now. Don't think like that. So now, I dash. Image we are measuring below the principal axis, which means under the principal axis or downwards the principal axis. We should have to take as a negative HI. Am I right? Okay. Is equal to O dash. O dash is a positive HO. So now if we are cancelling these two, so we are getting the formula is about HI by HO is equal to minus V by U, or V by U is equal to minus HI by HO. But this V by U mostly we are using in the case of lenses is positive V by U. Simply either if we are taking V minus V by U, we have to take HI by HO. But mostly you just have to remember minus V by U is equal to HI by HO. Okay, this is the magnification formula, and why we are getting minus means after applying the sign convention only we are getting the minus value. Simply remember magnification is minus V by U or HI by HO. Am I clear all of you? Fine. So that's all about the magnification. So now let me solve some problem which is based on the magnification, and also in the previous problem what we have done, so I gave U value, F value or V value like that, and I am asking you to find out the another distance. Based on the another distance, and also we can also find out the where the position of image is forming, where the position of object is there. Yes. So but now I am also asking in the questions, mostly previously 2-3 question papers, they are also asking you about the write the characteristic of image. So not only giving that for 4 marks question, they are also asking you write the characteristic of image. So now let me tell you one problem, the last problem. So one question is about one problematic question is about. So simply I am telling in the words, but I am writing directly. Here the question is, I am keeping an object. Not object. Here my image is forming at 15 centimeters. Image is forming at 14 centimeters. Sorry, image is forming at 14 centimeters distance. Okay, for a focal length is 5 centimeters. For focal length is 5 centimeters. Then what is the object distance? Okay, which means I am telling for a concave mirror the image is forming at 14 centimeters distance in front of a concave mirror, and which has a focal length is 5 centimeters. Then find out the U value, find out the object distance, and write the characteristic of image. Write the characteristics of image. Write the characteristic of image. Okay, and which type of image, which type of object you have to write. Am I clear? So now, so this is also you have to find out. So now we have our first task is you have to apply sign conventions. Yes, without applying sign convention directly, don't go for the calculation. Am I clear? So now see. So what is a V? So I am taking as a minus centimeters because they are only telling in front of a concave mirror the image is forming. So minus I am taking. F is also minus 5 centimeters. So now from mirror formula, 1 by F is equal to 1 by V plus 1 by U. Substitute these values here. 1 by F is a 1 by minus 5 is equal to 1 by minus 14 plus 1 by U. Here don't write U is a minus. Whether we will be get whether U is positive or negative, you will be get by the calculation only. Here applying U is also negative now. Don't write here. Okay. After getting the value, you will only get whether that is positive or negative. Okay. So we'll see. So I am taking minus 5 plus 1 by 14 is equal to 1 by U. So for 14 and 5, this is a even and this is a normal prime number, no? So both will not be going the same table. So directly I am writing 5 was a 20. Okay. So directly I am writing 14 5s are okay 60. Am I clear? 60. 20 sorry 70. The LCM is a 70. Okay. So now 70 is a LCM. So now 5 minus 14 plus 5. Antena? So 5 14 is a 70. 14 5 is a 70. Finish. Now 1. So minus 14 plus 5. So answer will be how much? Minus 9 by 70. So we need u value, not 1 by u value. I already said u. So now u is equal to minus 70 by 9. So 9 7s are 63. So again 7 will be left. 7.7. So u is a 7.7 centimeters, which is minus. Okay. U is a minus 7.7 centimeters. Okay. See, f is minus 5, v is 14. Then f is 5 means radius of curvature will be 10. Yes, r will become 10 because 2f na, so it will become minus 10 centimeters. But object is there at 7 centimeters distance, which means in between f and r. Am I clear? So if it is f and r, the object is forming beyond c. Beyond c means c is there at which distance? Say 10 centimeters. Correct only na? We are getting image distance, they only gave 14, which means beyond c only. Am I clear? So now our one more task is we have to also tell characteristic of image. Am I clear? So now here you have to write magnification value. If we have a height of the object and height of the image, we have to go for the HI by H4 value formula. But here we having UV value na, so we just have to substitute these values only. So now magnification is equal to what is V minus 14 by minus 7.7. Okay. Or instead of writing the 7.7, I can also write again the same value minus 70 by 9. I can also write like that. So now m is equal to minus 14 into 70 by 9 means 9 by 70. So 7 2s are 7 10s are 2 1s are 2 5s are. So now m is equal to minus minus will be cancelled now. Minus minus will be cancelled. Okay. So both will be minus v by u. Already minus is there. Sorry. Already minus is there. Minus minus will be cancelled. Again minus will be there. So minus 9 by 5 will be left. So 5 1s are and 5 8s are 1.8. M is equal to minus 1.8 centimeters. Here 1.8 is greater than 1 only na, not equal to 1. So if M is greater than 1, then you just have to remember large image. Bigger image will be formed. If M is less than 1, smaller image will form. But here greater than only na, that's the reason large image will be formed when the object is when the image will be formed beyond C. If you observe, so I'll draw later. If you are taking a concave mirror like this, if you are keeping here at between F and C, okay, the image will be formed beyond C means here larger than the object only. Okay, so which I have explained in the case 3, I think. Okay, so now if M is less than 1, smaller size. If M is equal to 1, same size image will be formed. Then either that is virtual or real. Either that is virtual or real. How can we know? Means if M is positive, let me write. If M is positive, it is a virtual image. But here M is negative only na. Yes, M is negative only na. So that is the reason whenever M is negative, that is a real image. So let me write neatly once again to you. Okay na? Based on the two different cases, and let me explain about this magnification in details in the next video. and otherwise it will be too long. The length of the video will be too long. So let me explain this all, the magnification, and which type of, if the magnification is positive, negative, how we have to take. Okay, all the things I will explain in the next upcoming video, and until that time please keep watching the video. And I hope this video, if you think this video is useful for your friends and your family, you just have to share this video to them, and subscribe the channel. Please like the channel, like the video, subscribe the channel, and if you have any doubts related to this, you just have to comment below, and please subscribe the channel. Thank you for watching the video. Thank you so much.